All right, we're looking at our vector summary, just a few exercises to see if you're all good with the concepts that the ways we use vectors. Which quantities do we deal with that are vectors? Position is, change in position therefore is, all the velocities, vi, vf, v bar, acceleration is a vector, and forces are vectors. All of those things have both magnitude and direction. Time, speed, distance, none of those are vectors, but everything else really we have is vectors. Okay, each involving two parallel vectors a and b, we're going to use tail-to-tip addition. So the way that works is if I'm taking a plus b, here's my vector a, I move my vector b such that its tail is on the tip of a, and then the sum is from the tail of a to the tip of b. So that would be, that vector diagram says a plus b equals c. I can also do that. Let's see if I did a that way. I could do b this way. And then c would be like this. So all of those things tell me that a plus b equals c. We don't normally write the vector symbols on our things. We just, if we're doing algebra with the vectors, we're doing them in components. But next year we'll do things in full vector form. All right, tail-to-tip addition with a pair that's not parallel to each other. So if I added a plus b, or b plus a, vector addition, like all addition, is commutative, then this would be c. Okay, illustrate the process for finding components of a. So if we have a vector a that's tilted some angle theta from the axis, then we know that's the angle between the horizontal in particular. What I'm doing is breaking this up into, a goes to the right and up, so I'm breaking it up into a vector to the right and a vector up. The cosine of the angle is the adjacent side, which is this one, divided by the hypotenuse, so I can solve for the adjacent side, figure out that it's a cosine theta. And similarly for sine, the opposite over the hypotenuse. So I solve and I get a sine theta. If you're breaking vector f up into components, you'll have f sine theta and f cosine theta. The only trick is to draw the triangle first. Make sure you have a right triangle with a being the whole vector, whatever it is, being the hypotenuse, and that these components are each perpendicular to one of your, or parallel to one of your axes. And then the question is just like, which one is the sine theta component, which one is the cosine theta component. Alright, so we have a vector a and its components are known this time. So let's say I know that ay is up and ax is to the left. So using tail-to-tip addition, just like we did over there, the total vector a is that way. Now this time, though, I don't know the angle. I could use either one. That would specify the direction, but I'll just choose that one. So I'm going to use trig here. I know ax and I know ay. So if I look at the tangent of theta, that's the opposite over the adjacent. So tan theta is ay over ax in this case. So theta is the inverse tangent of ay over ax in this case. But if you know components and you're going to the whole vector, you're definitely going to use trig. It could be inverse tan, or it could be another inverse cosine or inverse function. Now, if I want to find this length, I'm going up this much and over that much. So this over here, I can just use Pythagorean theorem. Okay, so if I'm using this to add up, say, like two forces, right? Let's say I have a force like this, and then I have a force that goes maybe down like that. So if I'm adding these tail to tip, I can also look at that as adding their components. I guess I shouldn't call them F1 and F2. I told you to call them A and B. So A and B, and I can break each one of them up into components. And so the total vector, the sum C, goes from the first tail to the last tip. And look at the components of that vector C. Horizontally, I have this component plus that component. So I'm adding those. I'm going to copy those vectors over here. So this is AX. This is BX if I put those tail to tip. And I'm adding those to this vector here, AY, plus this vector here, again putting it tail to tip, BY. So the total in the y dimension is just right there at the tip of BY. So this is my total vector C. So that's how we really work with vectors in this class. We do it with components. We just break all of our forces into components and then add up all the components. I mean, what I'm illustrating here is what you're doing when you're doing F-net equations. So if these are forces, your F-net would be this force is x plus this force is x. That's your F-net x. And your F-net y would be this force is y minus this force is y component.